Yeah, good evening children. Welcome to Akshara IT classes. This is Srinivas, your maths faculty. So, concept of units place digit. So, I'm directly concept of units digit. So, in our previous class, we have discussed about only concept of units digit of a number which are in the form of two powers. 2 power 4000, 2 power 5000 like that, right? So let us check for 3. Let us check for 3. Okay? Yeah. So what is the value of 3 power 1? 3 power 1 value is 3. Alright? Yeah, 3 square means 3 into 3. 3 into 3 is 9. 3 cube value 27. 3 power 4. 3 should be multiplied itself 4 times. So nothing but 81. Right? Now 3 power 5 value 243. Am I right? Yeah. So while you are observing here, 3 power 1 ends with the digit 3. 3 square is 9. 3 cube ends with the digit 7 and 3 power 4 ends with the digit 1. Again 3 power 5 ends with the digit 3. That means it is repeating. See, your starting is ends with the digit 3. Again 3 power 5 is ends with the digit 3. Again 3 power 6. 3 power 6 is ends with the digit 9. That means after 4 terms the sequence is repeating. Am I right? After the 4th term the sequence is repeated up to 4. Up to 4, that means 3 power 1 to 3 power 4, the sequence is repeating from 3 power 5 to 3 power 8, next 3 power 9 to 3 power 12 like that. So for every 4 terms the sequence is changes, that means repeats. It is repeating the sequence. So that means if you find the units place digit of 3 power 159 is ends with the unit digit. 3 power 159 is ends with the unit digit. We just identify that 3 powers are repeating for every 4 terms. So that means this 159 should be divided with 4. Yes, 4 3s are 12. So remainder is 3 and 9 is bring down. 3 9s are 36. So remainder is 3. There is no other digit to bring it down. So we can write this 3 power 159 we can write as 4 into 39 plus 3. So it is nothing but 3 power 4n plus 3. Simply the first term is 3 power 4n plus 1. It is ending with the digit 1. 3 power 1 is nothing but 4n plus 1. 3 power 4n plus 2, 3 power 4n plus 3 and 3 power 4n plus 4. Okay, now that means 3 power 1 is ending with the digit 3 as well as 3 power 4n plus 1 also end with the digit 3. 3 square end with 9 as well as 3 power 4n plus 2 also end with the digit 9. Same way 3 cube and 3 power 4n plus 3 end with the digit 3. So simply, 7. Simply 3 power 159, that 159 we have expressed as 4 into 39 plus 3. That means it is in the form of 4n plus 3. Your n value can be any positive number. N value can be any positive number. So it is in the form of 3 power 4n plus 3. So its unit digit is, what is the unit digit? Yes, it is ending with the digit 7. Okay, na? Yeah, let us see this. 333 whole to the power of 2015. Here last digit also 3, right? That means we can directly apply the concept of 3. Concept of unit digit for 3, because here also unit digit is 3 only. That means the exponent should be divisible by 4. Because concept of 3 is repeating for every 4 times. Like concept of 2 also repeating for every 4 terms. Same way concept of 3 is repeating for every 4 terms. So this 2015 should be divisible by 4. 4 5s are 20. 0, 5 down. 4 3s 12. Again 3 remainder. Again 3 is remainder. So this 333 whole to the power of 2015. This can be expressed as 4n plus 3. In the place of n, we should write 503. So it is ending with the unit digit. Its unit digit is 7. Okay. So for finding these many times, for multiplying 333 into 2015 times, it is so much difficult for us, so we can apply the concept of 3 to identify the units place digit like this. Okay, na? So while you are observing here, I am writing here for 2 concept 2 power 4n plus 1, 2 power 4n plus 2, 2 power 4n plus 3 and 2 power 4n or 4n plus 4, both are same. 2 power 4n or 2 power 4n plus 4, both are same. So here it is ends with the digit 2 and this one is ends with the digit is 4, this is 8 and this is 6. Same way 3 concept 3 power 4n plus 1, because this is also repeating for every 4 terms, and 3 power 4n plus 2, 3 power 4n plus 3, 3 power 4n plus 4 or 4n, both are same. It is ends with the digit 3, 9, 7 and 1. Okay, na? Yeah, let us go to the number of our concept of 4. Let us check for 4 this time. You just remember this. These two are enough. Okay. So coming to the concept of 4. What is the 4 power 1? 4 power 1 value is 4. Next 4 square. 4 into 4 is 16. So it is end with the digit 6. 4 cube. 4 into 4 into 4. 16 4s are 64. See here. First one is end with the digit 4. Second one 6. Again 4. Again 6. That means 4 power 4 value 256. 4 6 4 6 4 6. Repeating like that. That means it is just repeat for every 2 terms. It is repeating for every 2 terms. So every 2 terms means we can easily identify, that is 4 to the power of even number, and next one 4 to the power of odd number. If 4 to the power of even number means 4 square only, no? So even number is ends with the digit 6. 4 to the power of odd number is ends with the digit is 4. Okay, na? While you are observing for concept of second and third, they are repeating for every 4 terms. That's why we divided with 4 table and we have it in the form of 4n plus 1, 4n plus 2, 4n plus 3, 4n plus 4. But here it is repeating for every 2 terms. Every 2 terms means among the 2 terms, while you are observing any 2 consecutive numbers, first one odd number means second one is even number. First even means second one is odd number. Because our number system is fit like that. That means even odd like that. So only 2 numbers it is repeating. That means one must be the even power, second must be the odd power. Even power is always end with 6. Odd power is always end with 4. Let us see one more example for this one. So directly you can say 4 1 is very 2. It is repeating for every 2 terms, no? So we can identify very easily. That is 1739. What is the unit place digit of 4 power 1739? 39. 9 is a odd number, so it is ends with the digit is 4. Simply we can identify. You no need to divide with 4 because 2 and 3 are repeats for every 4 terms, but 4 is repeating for every 2 terms, no? So among them one is even, one is odd. Now let us see this. 4 power 3, 5, 6, 8. The power value 3568 is even number. So even number is ends with the digit is 6. You can remember the concept like 4 power. For 4 power odd number and 4 power even number. 4 power odd number is end with 4. 4 power even number is end with 6. Okay. This is the concept for 4. Let us see the concept for 5. Let us see the concept of 5. Like 5 power 1 value is 5 itself. 5 square, 5 into 5, 25. 5 cube, 5 into 5 into 5, 125. Just observe here. All are having same unit digit or not? That means if you take any value in the power of 5s, whether it can be even or odd number, 5 is always end with the digit 5 itself. 5 is always end with the digit 5 itself. While you are observing unit place digit is 5 power 1, 5 square, 5 cube, all are ends with the digit is 5 now. So 5 power anything, any number you take, it is definitely end with the digit is 5. Okay now? 5 units digit is 5 only. Okay. Yeah, let us check for 6. So 6 power 1, 6 itself. 6 square, 6 6 are 36. See, here also it is repeating. So 6 power anything, like 5 power anything is ends with the digit is 5, no? Same way, 6 power any number, whether it is even or odd, it is ends with the digit 6 itself. Okay, no? Let us go through 7. Yeah, 7 power 1. 7 power 1 value is 7. Am I right? Now 7 square. 7 square value is 49. 7 cube value 343. 7 power value is ends with the digit 1. 7 power 5 value is ends with the digit 7. So here 7, 9, 3, 1. Up to 4 terms, the units place digits are different. Again, 5th term onwards, it is repeating. Like 2 and 3, 7 also repeats for every 4 digits, every 4 terms. Okay, na? So here also we need to identify like 7 power 4n plus 1, 4n plus 2, 4n plus 3 like that. So just tell me that 7, how 7 will come? 4n plus 1 is ends with the digit 4n plus 2, 4n plus 3 and 4n plus 4. Yeah, 4n plus 1, that means first one is ends with the digit 7. 4n plus 2 ends with 9. 4n plus 3 end with 3. 4n plus 4 end with 1. So this is for 7, 9, 3 and 1. Okay now? Concept of units digit. Let us go to 8 powers. 5, 6 are repeating continuously. 5 power anything is 5, ends with the digit 5 only. 6 power any number also ends with the digit 6 itself. Okay na? Now 8. 8 power 1 is 8. 8 square, 8 8s are how much? 64. 8 cube, 8 cube value is 512. So observe the unit digit. First unit digit is 8, second digit is 4, third digit is 2. Now 8 power 4 is end with the digit is 6. Because 8 twos, last digit we can multiply. 8 twos are 16, 6 enough. Same way 8 power 5, 8 6 are 48, again 8. So again after 4 terms, 8's also concept of 8 also repeating. Am I right? Yeah. So like 2 3 7 8, 2 3 7 8 are repeating for every 4 terms. So 4n plus 1, 8 power 4n plus 2, 4n plus 3, 8 power 4n plus 4 or 4n. So first one is ends with the digit 8. This is 4, 2, and the last one is ends with the digit 6. Okay, na? Yeah, 9. What about 9? 9. Yeah, 9 power 1 is ends with the digit 9. 9 square. 9 square is 81, ends with the digit is 1. 9 cube. 9 cube is ends with the digit again 9. So while you are observing here, 9 is repeating. That means 7 is repeating, 9 is repeating for every 2. So first one we can take it as odd, second one is even. So 4 power odd number end with the digit 9. 9 power odd number end with the digit 9. 9 power even number is end with the digit is 1. The concept of 9 here. 9 power odd, 9 power even. Odd is end with the digit 9. Even always end with the digit is 1. Okay now? Yeah, please note it. Just remember this. 2 to 9 concepts. Whether the unit plate digit is 0, 0 always end with the digit 0 only, no? That's why we did not discuss about 0 and 1. 1 also and always ends with the digit 1 only. 1 power anything 1. Right. Okay, next one. So we have already discussed about that congruence rule, right? If a, b, c are any 3 integers, or a, b, n are any 3 integers, we can express that, or we can write the 3 integers like a is congruent to b mod n. That means n divides a minus b. That means n divides a minus b, or a minus b is divided by n. Anything is same. If you are having that oblique like this, n divides a minus b, where b is the remainder. And also we have discussed some congruence rule also. a1 congruent to b1 mod n, a2 congruent to b2 mod n. We can apply the arithmetical operation between them: addition, subtraction, multiplication and division. Okay, na? Clear? Yeah. Same way, we can take the constant also. Constant we can apply both sides. A plus k is congruent to b plus k mod n. We can apply the powers also. A power m is congruent to b power m mod n. Clear? Yeah. So let us see some exercise problems based on these concepts. Practice sheet. Yeah, practice sheet. First one, if A is congruent, yeah, let us see this. Second one, practice sheet. Yeah, see here, practice sheet, first one. If A is congruent to B modulo N, that is nothing but the symbolic form is A is congruent to B modulo N, which means N divides A minus B, or A minus B is divided by N, both are same, okay? So while you are writing, both you should understand. If you write like this, you should read as A minus B is divided by N, If you write like this, n divides a minus b. So this is our required option. Now let us go to the second one. There are two congruents are given. A1 is congruent to B1 mod n and A2 is congruent to B2 mod n. Then which of the following is correct option? So if you have two congruents like this, we can apply 4 arithmetical operations between them, right? So A1 plus A2, let us see the top. I am not writing the options here. I am just writing the properties of these congruent rules. Let us see this. So A1 plus A2 is congruent to B1 plus B2 mod n. That means LHS parts we can add, RHS parts we can add. Arithmetical operation plus. For minus, A1 minus A2 is congruent to B1 minus B2 mod n. Multiplication, A1 into A2 is congruent to B1 into B2 mod n. Okay. Fourth one, A1 by A2 is congruent to B1 by B2 mod n. 4 arithmetical operations we can apply like this. And powers also we can write like A1 power m or A power m is congruent to B power m mod n. So among these congruent rules, we have some more congruent rules, but we don't know all of them. So according to your question, this is the option we required for second question. Now let us see the third question. Yeah, I am writing here. Third question is, if 36 is congruent to x modulo x mod 5, then x is, yeah, here if you take the general form of a congruence rule, if A is congruent to B mod n, A minus B divided by n, that means we have discussed in previous class, that is B is the remainder. B is the remainder, right? That means here x is the remainder. X is the remainder. When it is remainder, if 36 is divided by 5, 36 is divided by 5, the remainder is x. The remainder is x. So let us divide this. 5 table 5 sevens are 35. 1 is the remainder. 1 is the remainder. So from this we can say that x value is 1. X value is 1. Okay, na? Yeah, just I am erasing this. First two questions. Let us go to the next problem. Very short answers, these are all right. So we'll go to the next problem. Problem number 4. The units place digit. Yeah, we got the concept here. Units place digit of 4n plus 3. 3 power 4n plus 3. 3 power 4n plus 1. And with 3. 4n plus 2 with 9. 4n plus 3 and with the digit 7. So the units place digit of 3 power 4n plus 3 is 7. What is 3 power 4n or 4n plus 4? 1. Okay. So fourth question answer is 7. Question number 5. What is the units place digit of 4 power 4n? While you are observing that 4 power odd number, 4 power even number only will be here. But what is 4 power 4n? 4n is even number or not? 4n is even, because 4 is even number. If any number, whether it is even or number, is multiplied with even number, is always gives even number. Any number multiply with even number always gives even only. Same way 4 power 4n also even. So 4 power even number is ends with the digit 6. 4 power even number is ends with the digit 6. Got it right? Okay. So let us go to the next problem. Problem number 6. Yeah. So among the following numbers are divisible by 6. What are the numbers are given here? 56,783 and second option 54672 and the third one is 1 2 3 4 5 times 1 1 times 2 and fourth option is 45675. Yeah, which of the following? We have 4 options. Among the 4 options is which is exactly divisible by 6? Which is exactly divisible by 6? What is the 6th rule? Well, we are discussing about the 6th rule. 6th rule does not have any specific rule for 6. Number 6. Okay, because it is the combination of 2 rules. What are the 2 rules? If a number is divisible by both 2 and 3. Number is divisible by both 2 and 3. Then the entire number is exactly divisible by 6 table. Okay, na? So let us apply the 2 rule. What is the 2 rule? Last digit is even number or 0. 0 or even number. Let us identify them. This is odd number, not our required option. Second option is even, third also even, last one also odd number, not required. So we will have the required answer from option 2 and option 3. Because first one and the last one is not exactly divisible by 2 table. Okay, na? So if they are exactly divisible by 2 table, its unit digit is ended with the 0 or even number. But both are odd numbers. So our required options are only 2 and 3. Now rule 2 is satisfied. Let us check for rule 3. What is rule 3? Sum of the digits of a number. Sum of the digits of a number is divisible by 3. Let us add 5 plus 4, 9, 9 plus 6, 15, 15 plus 7, 22 plus 2, 24. Yes, sum of digits is 24. So our answer is option 2. Okay, now let us check here. Sum of digits is 7. 7 is not a multiple of 3. Clear? So while checking the 6th rule, we need to check 2 rule as well as 3 rule. Okay. So let us go to next question. What is the next question? Among the following, the number is divisible by 7. So actually the 7th rule we need to discuss. So it will take more time because 7 have specific, it is not having a specific rule, because if a number contains a 3-digit number, we are applying some different type of 7th rule. If it is 5-digit or 6-digit number, we are applying for different numbers. So different type of rules. So that's why 7th rule we can discuss some other time. So let us go to the problem number 8. So among the following, which is exactly divisible by 8 table. So the numbers 9635 4142, option 1. Second option is 374 50176. Third option 570 64214, and fourth option 87,462. Yeah. What is the divisibility rule for 8? Last 3 digits of a number is zeros or multiple of 8. Last 3 digits of a number is 0 or multiple of 8. So what are the last 3 digits? 142. 142 is multiple of 8 or not? Definitely it is not a multiple of 8. 176, last 3 digits. Yes, 176 is multiple of 8 exactly 2 times. It is divisible by 8. 214, 8 cube is 200. Yeah, sorry. Yeah, it is not exactly divisible by 8 table. 214 is not a multiple. Okay. 462, it is also not a multiple. So our required answer is second option. So based on that divisibility rule, last 3 digits are units place digit, tens and hundreds place digit. The digits in their 3 places, last 3 places must be multiple of 3 or zeros, then the entire number will be divisible by 8. Okay na? Yeah, please check. That is the problem number 8. Next, the last digit of expansion of 9 power 2000. Ninth question. The last digit of 9 power 2000. What is the ninth rule? 9 also repeat for every 2 terms. 9 power even number, 9 power odd. I have written here. 9 power odd number is ends with the digit 9. 9 power even is ends with the digit 1. Now what is here? 9 power 2000. 2000 is even number or odd number? It is even number. So its units place digit is 1. Its unit place digit is 1. Okay na? Same way, last problem from this practice sheet, 10th problem, that is 2010 power 5. See that what is the last digit here? 0. Before 5 minutes I have discussed this about 0. 0 power anything is 0 except 0 power 0 is not defined. 0 power 0 is not defined, but 0 power anything is end with the digit 0 only. So the answer for 2010 power 5 end with the digit is 0. Okay na? Same way 2011 also end with the digit 1. 1 power anything is 1 or 0 power anything is 0. Okay na? Yeah, that's it for today children. Thank you one and all. Have a nice day.